Hi everyone, today we will continue from the last part. In the previous tutorial we will try to see about the basic plot, that means the type 1, and the type 2, which is the mean performance and the stability, and the third one is which one where, which is type 3. So today we will see the remaining type of plot. So today we will see the discriminative versus the representative. So don't forget to incorporate the meta package into your studio. So you have to submit this one, and also you have to do this one, or you can continue by looking for the previous tutorial. So the discriminative versus representativeness will be our today's discussion point. So to do that, you have to use the function, you have to assign a name that you want here, then write the plot function and the GGE model that we are already submitted here. Then you have to indicate which type of plot you are going to run. So if you type 4, it will be the discriminativeness versus the representativeness analysis, and if you type 5, it will be examine the environment. So you have to type here for observing the representativeness of the environment. So type this one and submit to our studio. And further, if you want to look our biplot, so you have to use the function plot and type A means here. A means the plot, GGE model in the type is equal to 4. So submit it. So we'll get our biplot type 4 graph here in the right corner side of our studio. So this biplot indicates that the test environment representativeness of the mega environment. So since the average environment coordinate abscissa is the average environment axis, so the test environment that have small angle with the average environment coordinate abscissa will be more representative of the mega environment than those that have the larger. For example, Inan is larger, so the larger angle, so it is more representative. So if you have small angle with the average environment coordinate abscissa, it would be more representative for the mega one. So this follows that the pattern that means we are using here is SFP, which is equal to 2. So this is the cosine angle between any environment vector and the average environmental axis approximates the correlation coefficient between the genotype value in that or in the specified environment and the genotype mean across the whole environment. So based on this, we will classify the test environment into 3 types. For example, the first, the type 1, it is mostly have the shorter vectors, as only short vectors, and it's provide little or no information about the genotype and should not be used especially for the test environment. For example, if you select here the shorter vectors, the shorter vector is around E6, but it doesn't tell you which genotype is to be selected. So this type of environment should not be used as a test environment. And the second one is, it is environment having longer vector and also a small angle with average environment coordinate or abscissa. So you select the longer vector and as well as the small angle with the AEC abscissa, so that if you select here is E13 is longer vector, and as well as it also has a small angle. And also if you see here is also the E1 also is very small angle, and also to some extent have larger angle, but it's less compared to the environment 13. And the third type, what I want to stress over the type 2 is if the budgetary constraints condition that, or if you face the budgetary constraints which allows you only a few test environment, so I suggest you to select the type 2 test environment as your primary choice. And the third category or the third type of the environment is that have environment with long vector and also environment with what? With long angle. For example, E9 is the vector is longer and also the angle is comparing to the abscissa or the abscissa, which is also wide or larger. So this type of environment also cannot be used in selecting the superior genotype, but are useful in culling unstable genotypes. So based on this, sometimes you may reach to another conclusion. For example, useful test environments should be further examined for their uniqueness. So some of the environment may never provide unique information because as they are always similar to the other environments, and environments especially in separating and ranking the genotype. And in the similar fashion, some of this environment cannot be dropped cannot be dropped or without losing sufficient information about the genotypes. So the testing cost can be reduced and efficiency improved by using a minimum set test environment. So identification and removal of non-informative and redundant test location must be based on several year trail data. So for example, if you see in this graph, the E1, the environment 1, environment 11, environment 12, and environment 10 and 7, they are more or less they are similar, so that they will provide high correlated in the ranking of genotype, so which indicating that this environment produce similar information about the genotypes around them. So if this pattern is continuous year after year, or if it is repeated across years, then it can be concluded that some of them are what redundant or repeated. So it must be what drop. It must be drop. So on the basis of this one, I will select the type 2. The type 2 is that means, as I mentioned before, it's having what is a longer vector and smaller angle. It will be representative the mega environment. So let's jump to another type of pipeline, that means type 5.1. So type 5 is mainly examining of an environment. Well, that means identifying genotype most adapted to an environment can be easily achieved using the genotype plus genotype environment interaction. So you have to incorporate, here is our data name, followed by the environment genotype, then the response variable is explained, and also you have to write this symmetrical and submit to RStudio. Then you have to type here is 5, that means to examine an environment. That means, for example, if you want to which variety is bestly performed under the environment 10, so you have to add this E10. Or if you want to check which genotype is performed in environment 9, you have to type E9. Or in E1, that means if you type E1, so it will show you those genotype is bestly performed under the environment 1. So let's use this example for the E10. So for environment 10, so we will identify which genotype is bestly fitted to the environment 10. So write this syntax and submit to our studio. And again, also we will let's simply capture the first plot. So plot A, in order to minimize the time. So we will got our backplot graph type 5. So in this case, here is our environment 10 here. So the best genotype that are adapted to this environment is one. Here is genotype 8, and it's followed by genotype 7, followed by genotype 3, genotype 2, and also here is followed by genotype 4, genotype 1, genotype 6, genotype 5, genotype 9 and 10. So the highest yielding genotype in this, based on this graph, is G8, while the lowest yielding genotype is genotype 10. So the order of the genotype on their performance will be started from nearest to the environment to the furthest one. So it started by G8, G7, G3, G2, G4, G1, G6, G5, G9, and G10. So let's jump or skip to the type 6 biplot. The type 6 biplot especially deals with ranking of environment, and this ranking of environment used to select the ideal environment on the basis of the concentric lines, and these concentric lines serve as a ruler in order to measure the distance between an environment and the ideal environment. So the environments that are closest to the concentric lines are the more desirable, and the furthest are the least desirable. So in order to do that, you have to type this one on your RStudio, and again also we have to submit the type 6. Type 6 means by default will tell you that the ranking environment. So you have to type this one and incorporate it. So even also you want to draw further plots also, in order to modify your plot, you have to type this one on your RStudio, and then let's see the type 6 biplot looks like. Yeah, it's already displayed here. Let's zoom in. So on the basis of this, the environment 13 is very close to the concentric lines, and it's followed by environment 5, environment 1, and again environment 10 and 12, and the list is around the environment 4. So by this way we can determine which environment is best for or which environment is closely to the ideal environment. So on such conditions, E13 is very close to the concentric line, so it is the closest to the concentric line, therefore it is the most desirable comparing to all the 14 genotypes. So if you compare here also, E4 as well as E9 are the least desirable test environment. So this is all about today's tutorial, and we will continue the remaining type of biplot in upcoming videos. So if you are new for my YouTube channel, please subscribe, share, and provide your valuable comment through YouTube comment box. As well, you have to use my email, wavjira@gmail.com. Thank you for watching. Have a nice time.